as I said, we're going to be in 2.7, composition of functions, day 2. So go ahead and have that out if you don't already. So we're going to continue looking at, we're going to be continuing to look at compositions. We started looking at compositions yesterday. And we're going to continue looking at our compositions today. Now, yesterday we looked at compositions analytically with equations, where we took an equation and plugged it into another equation. Today we're going to be looking, we're going to have equations, but we're also going to be looking at how we can do it graphically, numerically, and verbally. So all our different forms of functions, those are the 4 different forms that we can look at: graphically, analytically, numerically, and verbally. Those are our 4 different types, and that's what we have here. We have each different type representing 4 different functions. So we have a graphically f of x, the function f of x, is represented by this graph. Then over here we have g of x is represented by the table, so that's numerically. H of x is represented analytically with that piecewise function. And then k is represented verbally. Now, before we move any further, let's go ahead and get from this verbal representation, let's get an analytical representation, the actual equation of k of x. So, it tells us k of x is a quadratic function. Now, since it is a quadratic function, we're going to be using the quadratic form. So, quadratic function, we would have y equals x squared. That is kind of our parent function. We want to rewrite this with the transformations that are shown. So what 2 transformations does it tell us here? A horizontal translation, and what else? All right, so we're going to have some horizontal translation and a vertical translation. And that will represent our k of x. So, what horizontal translation did they tell us? Now, also translation. If they ever say that, that's just means shift. We've used the word shift a lot more in this class than translation, but it's the same thing. All right, what horizontal shift or translation do they tell us? What is the horizontal translation? 2. Now, is that 2 to the left, 2 to the right? Why would it be 2 to the right? It's a positive 2, right? So if this is a shift right, what should I put inside those parentheses? X? Exactly. So since that is a shift right 2, I should have x minus 2 in there. And then what kind of vertical translation do we have? Okay, is that up or down? So what should I put outside the parentheses? -4, -4. And there's k of x. Now, if they told us there was a dilation or something like that, we would have to input that as well. All right, so there is k of x. We have f of x as the graph, g of x as the table, h of x as the piecewise function, k of x now is that quadratic function. So we are going to go through and evaluate each of these compositions. If possible, remember there's always that caveat of it's possibly not possible. So let's go ahead and do A. So f of g of 3. So which one do I look at first? What did we do yesterday? F of g of 3. What do I do first? Plug 3 into g. So let's go find g. Now this 3, this is an x value. X equals 3. So let's go to what is represented by g. Which one of these is g, function g? Our table, right? So let's look at our table. What would be g of 3? What would be g of 3? It'd be 4, right? Because this is asking us, what is our value when x equals 3? So this is g of 3. If it helps, you can write out each of these. Say this is g of -4, g of -2, and so forth. If that helps you, you can. You don't have to. But that is g of 3, 4. So let's go down to our problem here. So this, what does this become then? F of 4, because g of 3 equaled 4. All right, now we need to find f of 4. So what am I going to look at for f of 4? The graph. So let's look at our graph. We want f of 4. Where would I go to find f of 4 on this? Remember, this is f of x. So what is 4? Our x value. So then where am I going to go? Where x equals 4. Here's x equals 4. And where do I go to find f of 4? To the point. All right, what is our y value at x equals 4? 1. So what is f of 4? 1, right? F of 4 equals 1. So then I go back to my problem here. So what is our answer? F of 4 equals 1. So even though I didn't have an equation, I still was able to get this by using the information given. So we started g of 3, we used our table, found that value. Once we had that value, we were able to find f of 4 using our graph. So what I'd like you to do is go ahead and try B and C to start. Try B and C using that information, and then we'll check in about a minute or so. So B, we're looking for h of f of 8. So what function are we looking at first? F, right? So what is, according to our graph, what is f of 8? -1, right? We have 8. Here's our point, -1, right? That's 8 comma -1. So down here, we would then say that that would be h of -1. So what function are we looking at now? H. That's this one. If it will show up, there it is. So this is a piecewise. We want to know what is h of -1. So which one would we use? The first one. Why the first one? The x values in question are less than -1, and -1 is less than 1, right? So remember, with the piecewise function, we do not plug it into all of them. We only look at the one that fits. And in this case, the top one is the one that fits. So let's see, that would be absolute value of -7 plus 3 times -1. What does that equal to? Absolute value of what? -10. What's the absolute value of -10? 10. There we go. So B is 10. Let's see. On C, what function do we start with? K. So what is K of 0? How did you get 0? Plugged in 0 to K, right? So that'd be 0 minus 2 squared minus 4. That'd be 4 minus 4, so definitely is equal to 0. All right, what do we look at now? G. Which one is G again? All right, so we want to know what is G when x equals 0. But looking at your table, do we see x equals 0? No. So what did I highlight over here again? So is this one possible with the information given? No. So this one we'd have to say this is undefined. It's not possible. Not possible. It's not within the defined domain of G. Now, if we are given other information about G, maybe we could figure it out. But all we are given, all we are defined is that table, nothing else. We cannot assume, we cannot guess, so we just say it's not possible. All right, I want you guys to go ahead and try D and E, please. D and E. F of 2, or rather, F of 2. Ellis, what did you do for D? Good. And that's equal to 4. Good. All right. How did we do on D, guys? Do good? All right. E. Adriana, help me with E. That equals pi. Good. Did we all get pi? Especially add with some real pie. Delicious. Anyways. All right. Now this one. It looks crazy, right? But it's actually not that bad. Again, I like writing it with the parentheses. So I'm going to write it in this way. G of F of H of K of 4. Now, why would I want to write it in this way? Any thoughts? We can see it a little bit better, right? What have we been doing? Where have we been working or starting at? The center, right? The middle. So let's start there. So what does this tell us we do first? K of 4. What is K of 4? Looking up at your stuff. Is that 0 again? All right, there we go. So now that we know what that is, I can bring this down a little bit. So that's G of F of H, but now I know K of 4 is 0, so that's now 0. Make sure I have all my parentheses. All right, so what do we do next? H of 0. So what is H of 0? Negative 7 plus 3 times 0. So what does that equal to? All right. So now we know that that is G of F of 7. What do I do next? What is F of 7? Negative 2? All right, sounds good. So that's G of negative 2. And now we're there at the end. What is G of negative 2? 3? All right, there we go. 3? Yeah, 3. Remember, we look at the x value. So yes, there are 2 negative 2's, but which one do I want? The one that it's x equals negative 2. That's my G of negative 2 right there. All right, not that other one. That's y equals. That's G of 5. All right, so looked crazy, but was it all that bad? I'll just take it step by step. All right? Okay, problem number 2. Very similar. We have a graph for G and a table for F. So part A asks us to find f of G of 3 and G of F of 3. We can do that. It's not a problem now. And then it asks us if they're equal. Great. Part C is f of G of 2. Again, we can figure that out. What I want to look at is part D. What do we have different in part D than all the rest that we've been looking at? There's a number in front. But what do you think we would do with that too? Just multiply it. So we do exactly the same thing. We just do that operation that we have. So let's go ahead and do part D. So that is 2 times g of f of negative 1. What is f of negative 1? Yeah, 0. All right, so that is 2 times g of 0. Well, now what is g of 0? Negative 4. We look over at the graph. There's 0. There's our point, 0 comma negative 4. So that is 2 times negative 4. So what is our final result? Negative 8. So even though we have that number in front, we just apply the operation that we see. Same idea for E. So let's go ahead and look at E real quick. So this is for x equals 4. So that's f of g of 4 plus f of 4. So what do you guys think we would do? What would I do with my 4? Plug it into g and f. So what is g of 4? What do they tell us? 1, right? G of 4 is 1. So that becomes f of 1 plus, what is f of 4? 5. And then what would I do? So what is that? F of, and then what is f of 6? There we go. All right, everybody, I want to go ahead and finish out with our function decomposition that we have here. So we've been doing the function compositions, where we've been putting a function within a function. Function decomposition means that we can decompose a function analytically into less complicated functions, meaning we can break down one complex function into multiple smaller, less complicated functions. By doing this, we can solve for functions in shorter, easier to understand pieces. So for example, in problem 4, we have that h of x equals, really h of x equals e to the x to the third. That's pretty complex, right? We have a power within a power. So they ask us to decompose h by identifying f and g. Now they're showing that f and g, so this is f of g of x. So we really want to know what is kind of the outside function and what is the inside function that was originally plugged in. Well, in this case, if we think about this as being e to the some power, and that power became x to the third, then I would say f, the outside function, f of x, would just be e to the x. Whereas g of x, the one that was plugged in, is x cubed. And then if you think back to our function composition, f of g of x, or f of x cubed, that becomes e to the x cubed, which is our function h. So this would be our function composition. So I'll go ahead and do one more problem, problem 5 here. We have h of x equals 1 over x plus 4. And we want to know what is that composition. Again, what is the outside function? What is the inside function? Well, it looks like this is 1 over something, and that denominator became x plus 4. So I would say what was plugged in, our inside function, is x plus 4. And the outside function, f of x, would be 1 over whatever was replaced with x plus 4, which I would say x, right? So if I took that and did our function composition f of g of x, I would have f of x plus 4, which would be 1 over, instead of 1 over x plus 4, which is our h of x. So this would be our function composition. We're just kind of pulling it out, figuring out what was that inside function that was originally plugged in to get this composition. All right, and that's going to go ahead and end this lesson. Thank you for watching.